All right, well, why don't we get started so we don't run long, so you can get out for dinner and beer or whatever at 6 o'clock. So welcome, I'm Ariel Anbar. I'm the president of the Biogeosciences section. And on behalf of my co-organizers, Steve Romaniello, who's standing there, Hillary Hartnett, Linda Rowan, who may or may not have gotten here yet. There she is. I'm pleased to welcome you to this union session, Can We Manage Earth's Future? What might it mean to manage Earth's future? Is it even possible, considering the complexity and scale of the challenge? If it is, manage it for whose benefit? And to what end, since management requires a goal, and right now humanity can't even seem to agree on present realities? So it's hard to know, but here's what we do know. As humanity's influence on Earth increases, we need to bring together the study of human behavior and motivations, the provenance of the social sciences and humanities, together with the natural sciences. For example, as one of our panelists, Ken Caldera, put it this morning during a Sagan lecture, if you take a planetary perspective, economics can be seen as a branch of biology. And at the same time, we know that classical economics doesn't capture the complex drivers of human behavior, which include beliefs and values that are the domain of the humanities. So this integrated science that melds an understanding of humans with an understanding of the planet is going to be central if we're going to navigate the Anthropocene. So this is a daunting challenge, and our goal here isn't to solve that, but to begin or maybe continue a conversation that might get us there. And so to that end, what we've done is we've invited 4 leading environmental scholars who together span these domains, and we've invited one of the world's leading environmental journalists to foster the dialogue. So I want to say a few words introducing each of our panelists. So Ken Caldera is a pioneer in studying the environmental consequences of climate change and how we might avoid them. For this research, he was appointed as an AGU fellow in 2010. He's also become one of the more influential voices beyond the traditional science community. For example, in 2016, Bill Gates described him as my amazing teacher on matters of climate and energy. He works at the Carnegie Institute for Science. Kate Calvin is a research economist who's a rising star in the study of how humans affect the environment and how humans respond to a changing environment. She does this by developing and applying complex computational models, so-called integrated models. Kate works at the Pacific Northwest National Laboratory's Joint Global Change Research Institute, where she was recognized for early career exceptional achievement in 2015. Earl Ellis is an ecologist and geographer who studies the role of humans in landscape ecology. A leading scholar of the Anthropocene, he argues that in the Anthropocene, the biosphere is being so thoroughly reshaped by human systems that we need to think of Earth's future as one permanently managed by humans. He recently outlined his views in a book, Anthropocene, A Very Short Introduction. He's happy to give you a copy or point you to where to buy one. And he's a professor at the University of Maryland, Baltimore County. Joni Adamson is a professor of environmental humanities and a leader and pioneer in this field. It's a field that seeks to bridge natural sciences and humanities by recognizing humans as part of a larger living system. Joni's particular focus is environmental justice and indigenous peoples. She seeks lessons for our future in the cultural perspectives that indigenous peoples have developed about the relationship of humans and the planet. Joni leads the Environmental Humanities Initiative at Arizona State University. So thanks to all of you for agreeing to be part of this session. And to moderate this session, I'm thrilled to welcome Andy Revkin. Andy's a journalist who's become one of the leading chroniclers of global change and humanity's response to it. He did this over a 30-year career that took him from Discover magazine to the New York Times to ProPublica, and now to the National Geographic Society, where he serves as a strategic advisor for environmental and science journalism. Along the way, he's earned many accolades, including in 2015, the AGU's Robert C. Cowan Award for Sustained Achievement in Science Journalism. So I'm going to turn it over to Andy here in just a moment. The format here is Andy's going to say a few opening remarks designed maybe to provoke and inspire. And then each of our panelists is going to speak for up to 15 minutes. If they need less than 15 minutes to give their opening remarks, then we'll have some Q&A on their specific comments. And then after that, that'll consume an hour, and then we'll have an hour of open panel discussion moderated by Andy. So with that, I turn it over to Andy Revkin.
Thanks, Ariel. Thanks, ASU. Thanks, AGU. I don't have slides. I have objects. And I've been a sucker for the idea of management for a long time. As a journalist, starting on global warming, let me just grab a couple more things here. Issues like global warming back in the mid-1980s, my my first cover story in a magazine on global warming was 30 years ago last month. Well, 30 years ago in October. You know, and it's kind of got everything in it that we've all been writing or thinking about ever since. Rising seas, drought, flood, blah, blah, blah. But back in the 20th century, it felt like, well, this is one of those pollution things, so we just solve it like we solved all those pollution things back in the 70s, et cetera. And then as you all, most everyone in the room knows, this is way bigger than a pollution problem. And so all those templates started to dissolve. And along with that, my idea of management as being sort of the way to think about it. But I'm still a sucker for it. So I'm just going to quickly read you a couple of things about management of the environment. When I was in 1977, before I was a journalist, I was a biology undergrad at Brown University, and I spent a semester in London, and I went to this book. They had a lunchtime book selling thing by the Farrington station in London, and these carts would come out with books. And I kind of bought this book just because I thought it was cool looking, and it had a neat map. It was an oceanographer named Matthew Fontaine-Maury, who I'm sure many of you know, is essentially the father of the American field of oceanography. And I don't want to rip the map, but it's amazing. Infographics, 1859 style. And it had this amazing line in it. He talked about the atmosphere. There's a very poetic section on the atmosphere takes up CO2 here and moves it around, and it's sucked in by the plants of the Nile. And he says, hence, to the right-minded mariner, and to him who studies the physical relations of earth, sea, and air, the atmosphere is something more than a shoreless ocean at the bottom of which we creep along. It's an envelope or covering for the dispersion of light and heat, and goes on, extolling this dynamic machine. And then he says, upon the proper working of this machine depends the well-being of every plant and animal that inhabits the earth. Therefore, the management of it, its movements, and the performance of its offices cannot be left to chance. So that's 1859, that edition came out. And fast forward, in 2002, halfway through my tenure at the New York Times, I convinced the science editor to do a special section of the weekly Science Times on managing planet Earth. Because I was talking to a lot of people, Bob Cates and others, Bill Clark at Harvard, sustainability science. So this whole issue was devoted to the science of the dynamics of the Earth and what do you do about it. And it had a line, that's when I really dug in on this guy, Vladimir Vernadsky, a Russian geochemist who, in the early 20th century, along with a French theologian, Teilhard de Chardin, they circled in on this idea of noosphere, that not only were we going to manage the Earth, but that our knowledge and our connectivity and everything was building a planet of the mind. Our connectedness was going to lead us to being able to make the Earth a better place than it was. And Vernadsky had this line, thinking about noosphere, the Greek, he called it life's domain ruled by reason. So again, there's this rational concept of we're going to fix it or manage it. And so then fast forward to 2015, and I'm at this meeting in Manhattan, a conference on climate and civilization, and a modeler, a sustainability analyst for the EPA, Heriberto Cabezas, I guess he was a consultant, had a very sophisticated multidimensional model of the human enterprise, going forward in time 200 years. And his last slide, toward the end, he summed up his points, and one of them was, his conclusion, very sophisticated model, was the coordinated manipulation of at least 6 variables is necessary to maintain stability for 200 years or so. And as I'm hearing these words, some part of my brain is going, that doesn't feel like the world that I know. And I kind of did that sort of 6th grader thing, you know. And I raised my hand and I asked him, so I said that. I said, this doesn't really feel like the world I know. And he said this is a total quant. He's a mathematician, he lives in numbers. He says, well, why isn't this happening? We lack a cultural narrative that says sustainability is really important. We have a cultural narrative that says murder is wrong. We don't have a cultural narrative that says managing our planet in a way that allows us to live on it as long as we can is probably the most important thing. And that was interesting because he couldn't fall back on a construct or some mechanistic explanation of how to go forward. It was literally, there's something big missing. And that took me back a year earlier, 2014. I was at the Vatican for a week with a bunch of scientists and theologians and journalist or two, and all kinds of people at the Pontifical Academy of Sciences. And the meeting was on sustainable humanity, sustainable nature, our responsibility. And one of the scientists there was Walter Munk, who I'd known for 15 or 20 years. Even in his mid-90s at that time, he was still actively engaged with science. And I turned to him at the final dinner and I said, "So Walter, what's your sense of how we're going to get through this?" And he's a mathematical, physical oceanographer, not just sort of studying plants and the like. And I figured he'd say something, again, mechanistic or the like, something about fusion or geoengineering or whatever. And Walter said, at the age of 96, he said, "This will take a miracle of love and unselfishness." Okay, so that leads to this panel, I think, which is why I embrace the idea of being here. And I'm going to step down and let everyone else talk now, because it's, what are the limits of this concept of management? Or is there a new emergent form of management that's coherent with everything we know and don't know about how the human being works, either individually or as a 7.6 billion collective? So that's the introductory thought, and let's get to it. Thank you.
Hi, so I'll try to make my remarks brief, and really they're just, maybe you're going to hear a bunch of redundancy here, because I would just like to reinforce some of what Andy just said, that, I'll get to some of these slides in a second, but I think especially over the last 30, 40 years, there's this been kind of assumption that the local optimization in your narrow short-term self-interest is the fundamental way that human beings are. And that's the way it always has been, and that's the way it always will be. But I don't think that's the case. And if you think of people building Notre Dame over centuries, or other things that have engaged the human imagination, that I think people get meaning out of feeling that they're participating in something bigger than themselves. And I do think that the central challenge is fundamentally this, exciting people about the goal of producing a sustainable society and contributing to that. And you can say, okay, that self-sacrifice of your life grew up around kin selection, maybe in some narrow, close quarters, but routinely governments send young people out to get killed all the time. And people are willing to give up their lives for some greater thing because they've been acculturated in a system that gives value to that kind of sacrifice. And and I think if we can excite people about this project of trying to act as if we plan to live on this planet for the long term, that people could get excited about that. And if we had political leaders inspiring people to do that, I think it could happen. And I think I think also the field of economics, by representing people as narrow local optimizers, have been have been encouraging this line of thought of humans as this narrowly self-optimizing automatons. And every parent has sacrificed themselves for their children and get nothing in return. Okay, I shouldn't say nothing, but that was extreme. But anyway, so let me just go on here. But anyway, what I'm saying is, I think sacrifice for others is something that we all routinely do, and get. It's not completely self-effacing. So when I help my postdocs or students or something and seeing their success, that gives me a sense of meaning and makes me feel good, and so I benefit from that. And so the idea that helping others and helping a broader goal is somehow antithetical to what being a human is, which is what the dominant paradigm has us asking to believe, just isn't right. So let me also just say, so we have people on the panel here, that Mr. Ellis here really influenced me by his comment about, we should imagine the Anthropocene as being good. It's like, it reminds me, I referred to Camus this morning about, we should think of Sisyphus as happy, and it seems almost like that kind of thing, that maybe it's a Sisyphusian task, but let's hope it can succeed. So, but anyway, one of the things, there's a kind of a feeling among many, and I'm coming out of the climate change community, and there's this feeling that, well, climate change is the big threat facing this planet, and it's certainly a threat facing the well-being of many people and many ecosystems. But we also have pesticides, the fall-off in the abundance of insects around the world, amphibians, there's all kinds of pretty dire things going on that, might ultimately prove to be maybe partly manifestation of climate change, but maybe ultimately even more important than climate change. And so we had lead in gasoline, we have pesticides and birds and insects and so on. We had the CFCs in the ozone layer and carbon in our fuels producing climate change. But let's say we solved all those problems, we're going to get hit with something else, because as humanity and civilization progresses, we're producing waste, we're inventing new materials and putting them into the environment, and sooner or later we're going to hit up against other barriers. And I don't see, like, where's the field of science that's looking for what's the sequence of barriers that humanity is going to be hitting over the next decades and centuries, and what are we going to do to prepare for those things or avoid those things? And material science is great. New materials is a lot of what propelled human advances over the last century. So we have silicon chips and we have carbon fiber and all of this, and but when we're introduced new materials, so creating new materials is great, but we really need to do life cycle assessments and really understand what's going to happen to these new materials when we release them into the environment. But I think a more forward-looking, anticipatory kind of Earth system science that's not just looking at problems that are already manifesting themselves, but can try to anticipate what kinds of problems we might be confronting down the road and trying to avoid those. And in my own department, we're hopefully have some hires, and I would love to try to hire somebody who was really surveying that broad sweep of possible threats to humanity and the other ecosystems on the planet, and trying to figure out what's going to bite us next. So anyway, I had the Carl Sagan lecture this morning, and Carl Sagan kind of, as with many things, highlighted this question, and I think it's on target, and I don't think we've been doing a good job. So, yeah, so this is, this is back to sort of this scale. I don't need to go on with this one, but I think it's really about cooperation, that the central question is really, how do we get people to cooperate to solve our problems and not act in narrow self-interest? And that, we've evolved as hunter-gatherers, where thinking about the long term was about storing enough nuts or whatever to last us through the winter, and thinking about large spatial distances was worrying about the village in the next valley. And now, we suddenly have to deal with things that are global in scale, that are centuries in scale, and our whole mental, emotional framework isn't evolved to deal with that. And so, I can hear on the news report about thousands of people starving to death somewhere in Africa or Asia, and meanwhile my cat can be meowing for some food in front of me, and I'll have a stronger emotional response to my cat meowing than hearing about thousands of people dying. And so we have to just say that, well, our emotional structures are not adapted to the technological world that we've created. And so we have to use our intellect to try to deal with problems at an intellectual level, because our emotional structures are no longer adapted to the world we've created. And and this is really tough when we have politicians that are preying on people's lizard brain and preying on their fears and exciting their most primitive kind of emotional structures, when what we really need to be doing is exciting their imaginations and their higher thought processes. So I guess this is back to my thing that that evolution has geared us to try to optimize fitness for the next generation to produce as much viable offspring, and now we've got to do something that evolution has never really done, of trying to optimize, at planetary scale, and or if not optimize, at least improve, and it's a huge challenge. And if I had to say what are the two elements for at least sort of like, for an environmental science type department, to me, it's anticipating the environmental consequences of materials that we're releasing into the environment or materials that we're extracting from the environment. And then from a sort of social science kind of perspective, I think this is like, what are the conditions on which people cooperate with each other, and how can we be altering our systems to do that cooperation. I've come out of a climate, actually I started with a paleoclimate background, got into sort of global change research, and now I'm feeling like, okay, enough of diagnosing the problem, let's try to work on solutions. So I've been shifting my group more towards energy system modeling. But I think, okay, if 100 years ago somebody had done a great energy system model, would that have helped the world? Would we be any better off today if we had a great energy system model in 1918? And I think the answer is no. But if people had worked on understanding what's the fate of materials that we released into the environment, maybe we wouldn't have poisoned children's brains with lead, and maybe if we had started then on trying to understand how to help people to cooperate more, that we'd have a little more cooperation right now and we'd be in a better position. So I think, both on the social science side and the environmental sciences, we have a lot to do. So thank you very much. Okay, I can do a couple of minutes for Q&A, although I don't have many answers, but you can ask your questions. Anybody?
I'll ask you one quick one.
Okay.
So it's hard, the backtracking thing is maybe useless, but which disciplines would you have wanted to have in your inquiry shop 10 years ago or 15 years ago that now you're kicking yourself over?
What, kicking myself over?
For not having them. Yeah.
For not having them? Well, I think the basic project that, I guess many of us have gone through the same transition, that we went from an information deficit model of social change where we thought, oh, the reason we don't have good policies is because we don't have information. And so we went into science to try to develop the information that would be used to make good policy. And now, I think we've come to understand that, kind of group identity and people want to protect their priors, and self-motivated reasoning play a huge role in decision making, and that that the information deficit model of global change really doesn't work. And so I kind of feel like a lot of time that I've spent generating information about climate change has been a waste of time, really this issue of how do we, I think how do we develop cooperation, I think is really what was missing before.
I could say the same thing about my journalism. And more.
Yes. So one here and then one there. Okay. What?
What do you think about genetic engineering and genetic manipulation as a science that has almost impossible to understand future ramifications?
Well, again, this is an area. Oh, the question is, what do I think about genetic engineering and so on? And, I guess as with many technologies, there's potential for harm, potential for good. I work near a Department of Plant Biology, and they talk about how by putting a gene in with a pesticide that they're producing crops that have 1% the pesticide, then when people are presenting pesticides onto fields, and then you're not killing all the other insects and all of that. And so, and a lot of plant breeding has been done by irradiating seeds in the 1920s and generating mutations in that way. And so, so my basic feeling is, nefarious actors aside, and then there's also problems with people like Monsanto making seeds, that it's not really, the problem is not genetic engineering, it's that somebody's owning this seed now and then they're charging people for it. But I mean, to me, the technology has, my sense is, without being an expert, that it has great promise, and that, I think that there's, I think there's too many people on this planet to think that we're going to achieve a good future by being kind of anti-technological, and it's through getting better technology that we're going to make a better world. And that's not to say that some technologies, obviously our fossil fuel energy industry has bad outcomes, and so these need to be regulated and monitored. But I would be very hesitant to discard a potentially valuable technology area just because there might be some potential for abuse. So let me just get to one more question, I'll be out. There was one more question somewhere. Oh, here it is.
Yeah, I want to thank, this is a great panel. Ken and both Andrew, you both got to the point about the real problem here, which is the problem isn't science. The problem is human ethics and culture and what we want to do, which makes me, I ask, we're talking to ourselves here. We should have the arbiters of ethics here, people from the religious community, people from, well, business involves ethics too, people to talk to about our science so that we are not really talking to ourselves about the challenges ahead, so we could work towards solutions. I guess it's more of a comment, but I guess I would like to get your feedback on that.
Okay, since my time's up, why don't we just let that stand as a comment and we'll move on.
That'll come up.
Wait,
Great.
I'm here.
Yeah, we'll
I'm here.
yeah.
Because this, we got to slide this back so that Kate can see her. See the monitor. So you can just move it.
Oh, yeah.
Over.
Okay. Thank you, and thank you for the invitation to speak. As Ariel mentioned, I'm a modeler, and so I'm going to approach this problem in a very different way than Andy or Ken might have, or the speakers after me. And so what I spend my time thinking about is how will humans in the Earth system co-evolve into the future, how do they interact, and how can we represent those in models. And so what I want to do today is to provide an overview of what I see as the state of the science and understanding these complex interactions into the future. And so I'm not going to bore you with long lists of studies that people here probably know, but we all know that changes in emissions affect the Earth system. So there's plenty of studies showing increases in CO2 emissions lead to increases in global mean temperature rise. Other actions that people take and also influence the Earth system. And so changes in land use and land cover change have implications for global mean temperature rise. What I'm showing here in this figure is just a study that I was involved in several years ago where we ran 2 different simulations in a complex Earth system model with just differences in land use, land cover. So we accounted for the fact that there's differences in emissions associated with that, kept all of that constant, and just swapped out land use, land cover, and you get dramatically different global mean temperature rise in the future. And so in this particular experiment, the deforestation world is much cooler than the afforestation world. It does depend on where you plant trees and to what magnitude, and there's lots of other uncertainties involved with that. Similarly, things like irrigation have implications on local temperature and local climate. And so these, sorry, I guess my co-panelists can't see my slides. And so there are other factors there. But at the same time that the Earth system is changing, these changes also have implications for human activity. So this particular figure is from the Agricultural Model Intercomparison and Improvement Project, and they looked at how changes in temperature, precipitation, and CO2 concentration affected crop yields. They also took that change in crop yield and fed it into a suite of agricultural economic and integrated assessment models. And what they found was, as yields go down, you need more cropland to feed the same amount of people. And so in this particular study, all of the economic models ended up increasing cropland area in response to these Earth system changes. The Earth doesn't just affect land use and land cover, there's also changes in temperature have implications for energy demand. And so this is a study that's looking at the change in building energy demand as temperatures go up. So when the temperature rises, we use more air conditioning and less heating. And depending on exactly where you are in the planet, those balance out differently. And so the states colored in blue here are places where the declines in heating energy demand more than offset the increases in air conditioning. The states in red are the opposite. Changes in temperature and precipitation also have implications for energy supply through things like hydropower, bioenergy, wind power. There's effects on water availability, economic activity, labor productivity. But much of the research in this area, in these two areas up until now, has largely progressed separately. And so the RCPs were developed assuming that the Earth system wasn't affecting human decisions. So those are just energy and land scenarios, and they have emissions that are assuming the climate is constant. Similarly, this study here on building energy demand didn't look at the changes in energy demand on emissions and climate, so it just stopped at the energy impacts. And so when we're trying to understand what the future looks like, we need to understand these stressors and how they interact. Put slightly differently, is the RCP 4.5 still a 4.5 world if we were to factor in changes in climate on energy demand, energy supply, water availability, and all of these different things? So this past year, I went with a colleague of mine, Ben von Lammerty. We wanted to survey the literature on human Earth system modeling. So what do we actually know? What studies are out there? How is this modeled? What are the big uncertainties? And so we really in particular wanted to quantify the strength and direction of feedbacks and identify gaps in the literature. And for the rest of my talk, when I say feedbacks, I'm going to mean feedbacks between the human and Earth system broadly, not feedbacks within either of the two systems, which are also important to consider. And so what we did was we did a systematic review of the literature, doing Web of Science searches and reading important papers, and we found a large group, set of papers that fell into some broad categories. So we found quite a few papers that were calling for this, so that said that in order to really understand the future, we need to either put human systems in an Earth system model or Earth systems in a human model. And so there were a lot of papers out there that were calling for that. There were a lot of other papers that were suggesting that this is really hard to do, and here are all the reasons why this is going to take us forever and be difficult to quantify uncertainties. But then there were several papers that actually tried to do this, and so those are the ones I want to focus on now. And hopefully this will provoke an interesting discussion going forward. And so we found 19 different studies that describing 11 unique modeling systems. And these studies varied in the complexity of the component models. So some were using a full complex Earth system model that needs a supercomputer. Some used a simple climate model. On the human system side, there were some using integrated assessment models. There were others just using statistical relationships to link the environment to human decisions. There were different scenarios simulated and different feedbacks represented. And so just as a couple of examples of what we found, so these are my human and Earth system models. And so there were a suite of studies that took emissions in land from the human system, put it into an Earth system model, calculated the change in climate, and then looked at what that change in climate did to the productivity of land and what that meant for land use and land cover change. There were another set of studies that started with the same way. So we're going to take emissions from the human system, put it into a climate model, calculate the change in climate, pass temperature back to the human system, and that temperature affects GDP. And so in general, what a lot of these economic studies show is that when temperatures go up, GDP goes down. And so that has implications for where we're going in the future. There was another couple of models that passed the same information, but they did something different with it. And so in these models, temperature affects behavior. So for example, in this one study, Beckett et al., which you'll see on the figures I'm going to show in a second, they assume that changes in extreme events lead to a different action taken in the future. And so you can think of this as a different level of mitigation effort. So people respond by changing the emissions pathway that they're on. And so they get a different answer there. And so just to give you some examples of what sorts of things you learn from studies like this, and I will give you as a big caveat here, this is 19 may sound like a lot, but it's not really, and so you're going to see quite a bit of uncertainty on the couple of figures I'm going to show you. And so this first one, and I'll spend a little bit more time on this figure just to understand what it's on, this is looking at the outcomes on global fossil fuel and industrial CO2 emissions. And so in this figure, as well as in the next one, I'm plotting the RCPs, which I think everyone here should probably know, as colored lines. And so these are just the traditional emissions pathways that don't include these feedbacks. And then the dots are what happens when you include feedbacks in different studies. And there's 3 studies listed here because those are the 3 that actually quantified CO2 emissions. And so what you find here is that these studies differ very different. They're very different in the feedback included, in the scenario described, and in the modeling system. And as a result, you get this huge range of what the inclusion of Earth system feedbacks on humans could do to CO2 emissions. So in the land productivity simulations, they find a small decrease in energy system emissions that's related to bioenergy. And so there's this feedback from climate to land to energy in that pathway. On this particular GDP study didn't really find a big effect on emissions. The study, including behavior, found a pretty large and widely uncertain effect here. And so in some of their uncertainty of their ensembles is that people respond to seeing these extreme temperatures by mitigating a lot, and others they don't. And so you get this really big uncertainty range here. You can carry that through to global mean temperature rise, and here you're seeing differences anywhere from a decline in temperature to an increase to next to nothing, depending on the feedback pathway included. And in each of these, I'm trying to give you a sense of whether or not these are big numbers by putting some other feedbacks on there. So as an example, going from one RCP to the next, which you can kind of view as a mitigation action, is about 1 degree C. These other natural system feedbacks are smaller. And so you get, both uncertainty, but there's also the potential for really large feedbacks here. And so that question of, is an RCP 4.5 still an RCP 4.5 when we factor in all these Earth system effects, I think is still largely unknown because we don't have enough studies here. And so just to close out here, I'm also trying to leave a lot of time for discussion. What I think we need in the future in order to really understand the coevolution of human and Earth systems is more modeling systems and more modeling studies. And so some of the questions when we were going through this paper is, how robust are these findings? We're getting different signs, different magnitudes. What do we learn from all of this? And what happens if you use an alternative model? So in the land productivity study, that was the opposite sign of what we had seen in the initial study that I presented at the beginning. And so you could have gotten a different sign of feedback there if you'd used a different crop model. How do these results vary across scenario or radiographic level? One of the things you'll find in here is building these models is difficult, and running them can also be difficult. And so there's often a very limited number of feedbacks and scenarios in the literature. And so how do we do this? And the question that's really interesting to me is which feedbacks are most important to consider? So I only showed you 3 here, but they might not be the most important. So what happens if we have changes in water availability? What does that mean for energy or land? And how do we really figure out what we need to consider? And then what are these implications of feedbacks at national and subnational scales? I was only showing you global effects, but we all know that distributional effects can be really large and might be incredibly important. So how do we look at those, and what do we make of that? And then I think we also need an intellectual framework for quantifying these feedbacks. So how do we isolate these effects, and how do we compare across these different studies? Is it fair to compare a study that looks at changes in behavior in a high emissions world with changes in land productivity in a lower emissions world? And so how do we do this, and where do we go from here if we want to understand these combined interactions? And so I'll stop there for questions. Okay. Yes.
So typically these kinds of models are meant to inform decision making. Yet when you put the human in the model, you're treating the decision making as kind of a deterministic response to the system. So just how do you think about this balance between informing decision making versus the representation of the decision as a deterministic component of the model?
Yeah, I mean, I think that there's all kinds of different uncertainties that I think are important to sort of explore. There's these sort of pure uncertainties that are just, climate sensitivity and things like that. Then there's uncertainties about technology and policy, which is more getting at actions and what people can do. And then there's uncertainties about how those play out. And the way that these are generally represented in these sorts of models is we try to do the best we can to get those in there and then explore wide uncertainty. And so if you're thinking about sort of policy or something like that, you run lots of them and look across them and look for robust findings. Yeah. Oh, there's some in the audience. Yeah.
There's a microphone there.
Mechanical question. I imagine that one of the reasons that there aren't a lot of studies that put these models together is because it's difficult to actually put the models together.
Yeah.
Could you talk a little bit about the problems that you ran into trying to connect one model from one sort of side or discipline to another?
Yeah. Yeah, and so there I would say there's a bunch of different challenges embedded in that. And so some of them are sort of just communication challenges. So if you're bringing together people from very different research communities, how they talk about the same thing ends up being different, or which acronyms they use. So you use GWP, means global warming potential to one community, growth world product to another. And so how do you even communicate as people? And once you figure out that you're talking about the same thing, when you're coupling these models together, you're dealing with challenges of different scales, both process, temporal, spatial resolution, different software coding languages, and so you often have to build these translators. And so there have been different approaches in the literature. That is why it's hard and there's a limited number of studies. So some modeling systems have gone through this. Well, once we get this together, we can actually use it to test hypotheses. So we're going to go through the effort of actually doing the software correctly, and we're going to spend a lot of time developing a tool that we can then use into the future. There's others that have looked at this as, well, maybe we just need to do some exploration. And so let's build these simple statistical models and test out which things matter before we go about the business of building a complex model. And I think that there are trade-offs with both. In the simple model, it's easier to interpret, easier to build, easier to understand, but you might be missing a lot of important processes and things like tipping points. So and those sort of nonlinear effects tend to not be in the simpler frameworks. The complex frameworks are complex.
I think we'll move on. And
yep.
Thanks.
Earl.
All right.
Tons of more questions.
Hard act to follow. Thank you, Ariel, for the invitation, a chance to talk about something that nobody knows the answer to, how to manage Earth's land, how to manage a planet. One thing we can do these days is we can see the planet as a whole for the first time in human history, but there's still no cockpit, there's still no dashboard that we can use to control this planet. We are in a position where, this is the one. We are in a position where we are doing things that nobody intends to do, that are changing the planet in ways that no one could have ever anticipated. And the classic example is the one you're all very familiar with. The Earth now glows at night. It never glowed before. To understand this phenomena of a planet that glows at night, you can't use physics. You can't use chemistry. You can't use biology. It's not that there's so many people on Earth that the Earth now glows at night. You have to understand the social processes, the historical processes, the engineering processes, the cooperation processes that have enabled a single species to create another type of planet than the one we had before. So when we think about the Anthropocene, this period of the planet that we now are in, we have to think about a process of social change is what is shaping this planet. And that social change is a process of cultural change in the very long term, at least. There's a tendency to think about our influence on the planet as a very recent and dramatic phenomena. And from a deep history point of view, deep geology point of view, it is a very recent and rapid phenomena that we are now able to change the Earth at such scale. And this is just an example of tropical deforestation. But when we look deeper at this kind of process, we find there's deeper roots. And this is just an example of deforestation has pulled away the forest cover in Amazonia and revealed an earlier society has already been there and transformed the land in the past. We've lived on a used planet for thousands of years. That's not a new thing. The rates and scales at which we're transforming the planet are new, but the idea that humans have been essentially not important to changing the Earth until the last 50 years or so is a misunderstanding of really where we are today. Now, of course, things started off relatively simple compared to where we are today, but there's nothing that simple about the earliest behaviorally modern human activities. And of course, this is a recent photograph of somebody doing shifting cultivation. Shifting cultivation is where this starts, but when we essentially get to a point where land becomes more and more scarce and populations and demands of populations become greater and greater, we don't see the simple process that has limited other populations from continuing to grow. Obviously, a lot of species can modify their environment in ways that increase the productivity of their environment, but humans are the best at doing this. We may think of humans as merely destroyers, but in fact, we have been successfully able to make this planet produce more for us than it would in the past. And we've done that more and more. As demand has increased, we've used more and more intensive technologies to transform this planet. Our societies have scaled up over time. What is the maximum scale of a human society? It's an unknown. It could continue to scale. We don't know. Over time, we've transformed the environment more and more to sustain ourselves, but we actually use less and less land per person to do this. So larger scale societies may use more of the earth to sustain themselves than smaller ones, but we actually use less land per person. We just transform it more. And of course, we use much more energy to do this over time. We've managed to substitute the energy from other species, animal traction, for example, biomass from plants. Now we've got fossil biomass. And interestingly, we're learning to use some energy outside of the biosphere to do what we want to do, such as solar and wind and nuclear. Nobody wants to go back to being the poor farmer. There is some directionality here. And this is actually an advertisement, the first successful advertisement for chemical fertilizer, and you could in China, and you could ask the question, as you should, of any advertisement: is this false advertising? And the answer is no. No. If you use synthetic fertilizer, you do get much bigger yields than you would otherwise. People are not wanting to live in the countryside as much as they used to. They're moving to the city. Urbanization is the most powerful force on this planet pretty much today. People are leaving the countryside, and as they do, the scale of the human operation continues to change. Agriculture is changing. It's becoming more large scale, and it's changing the way that it works. Large scale operations have huge investments. They're basically large industrial operations. They're not interested in low quality land. They're only interested in using the best land. But they, of course, bring with them all their own sorts of problems. And I would argue, over time, in a sense, we've been solving one problem by creating a bigger problem. Today, this is our situation. We're using about 40% of Earth's land right now for crops and pastures and urban areas. The only good news that you could see here is that, strangely enough, even as our populations have been exploding, nobody can deny that our populations have been growing rapidly lately, and people are actually eating better on average on this planet. And food supply, of course, has gone up to feed more people, and we feed better, higher on the food chain, more meat and such. It takes more food supply. But the amount of land used for agriculture is not increasing that dramatically. It's shifting around as the farming systems shift around. But it's not actually causing an accelerating growth. And for this reason, this shifting around is actually creating a lot of opportunities to do restoration. And in fact, with greater intensification of the land use system that sustains people, we have potential to do things differently. So some people see an image like this and they think it's the end of the world. Humans are controlling everything. We're everywhere. We are the most interconnected, most interdependent, most capable societies in the history of the planet. The idea that we live in a time without opportunity, a time where we can only stop the end of the world, is, I think, a great cop-out, and it's not looking accurately at our real situation. Our real problem, I would suggest, is that we don't have a vision. We don't have a common vision for a better planet. And of course, the biggest problem of all is that there is no we. What is a we? There is no we. So on one hand, we might think that there's really, in a sense, a simple way to manage the planet. We could just say there is a limit to how we can manage land. That's the simplest management thing. We set a target, 15% of Earth's land cultivated. That is the limit to what this planet can sustain. But of course, right now it's about 12 or 13. Whether that is actually an ultimate limit, who knows? And there's other prospects for defining some kind of limit. But arguably, that's not really the challenge that we face. Is 2 degrees, is that what we need to know to manage the planet? Unfortunately, it does not appear to be. So who are we? Who is we? And what does it mean to manage? There's lots of definitions. Manage can mean just to survive. We can manage it. Or can we actually take charge and guide it towards some kind of target? And who is we? Okay, is it just the scientists? We know. We can set a 15% target. Is it the nations of the world and their international negotiations? Is it consumers with their decision making? Is it the farmers and how they decide to operate? We have to think at multiple scales. There's not going to be one scale to answer this question. Every scale is going to matter, from the level of international treaties to the level of individual decisions, and we have to be ready to study those changes at that level. We shouldn't forget that there's a lot of people that live outside the so-called modern society. Indigenous people manage about a quarter of Earth's land, and they do it very differently. We've got programs already in place to attempt to guide land management decisions. Not all of them maybe the most well-designed and not doing so well, but the idea that we can't implement some of these targets, we can. International targets already exist. They're already underway. For example, the Aichi target for 17% of Earth's land protected by the year 2020. Probably won't get to 17%, but it has moved things up. We can also redesign the way food chains work so that consumers can have some influence over the way that land is used to support them. Now, global supply chains and certified deforestation-free palm oil is not working out so well, so it's still an imperfect system, but the idea that we can engage individuals, not just government decisions, but individual decisions in helping to do better is an important function that we need to engage with. Global Forest Watch is an interesting example, as it provides individuals with the opportunity to monitor what's going on in their regions. And indigenous people are actually using this tool together with apps to essentially report on illegal activity that can change things. And you can even manage your yard differently. It's all connected. It's all part of Earth's land. There's billions of people on Earth. It's a lot of yards, actually, although it's just one way to do it. We need to think about the Anthropocene as a design space. But what is that design space? Okay, we don't have every kind of opportunity. Okay, we've already transformed 3/4 of the terrestrial biosphere through a combination of land use and essentially isolating and fragmenting the rest of the planet within our working landscapes. About 40% of the land on Earth is already directly used. About a quarter doesn't currently have human populations or intensive land use. So those are kind of the two extremes, but there's a lot of land in between. Less used land, abandoned land, land in some kind of low-level forestry or even protected areas. There's a huge amount embedded within the working landscapes that cover about 3/4 of our land. And we can think of these anthropogenic biomes that we've created and sustained as mosaics. Everything is essentially embedded within a complex, multifunctional landscape. It's not like there's protected area over here and there's used land over here. We have to manage them together. And that's a very special challenge and a very difficult challenge because it puts conflicting demands of conservation and production for society together. You have to see the trade-offs directly. Now, it might be nice to think we do two things in the same space, it's all good, but of course, not always. But we can do things that are smarter. And in parts of Canada, for example, when you build a highway, you have to build a highway that includes transportation for other species. You can't build it just to one design. We can redesign our infrastructure and even our governance of our infrastructure in ways that can make it possible to actually sustain other species than just ourselves in the same landscapes. But we're going to have to do this under the challenging conditions of climate change. Even under the best case scenarios, we are going to experience a lot of climate change this century, and that's going to influence every other species on Earth is going to have to move and deal with this. And we've made it quite difficult. We've fragmented the planet into different pieces just because essentially we weren't thinking about what was going on with the rest of the biosphere. We still have left some areas behind, and like I said, we're closing in on 17% protected area globally. But those areas are going to be isolated islands. Species are going to go extinct in those habitats if they're not able to move across the continents to keep up with climate change. So there's a lot of management interventions at scale that are going to be needed to do this. And I think, again, this idea of vision. What should the biosphere be like? Not just how can we stop humans from destroying everything. What should the biosphere be like? And E.O. Wilson and Harvey Locke and some others have put forth the idea that we should conserve half of the biosphere for the rest of life on Earth. So this is the idea of an aspirational biosphere, not just one of avoidance, but one of looking for something better. And this idea that we could create another plan that isn't just about planning for production on a small scale, but looking at the planet in the future. What should this planet be like? And I'm not so convinced that showing a map to people of where there's going to be conservation, where there's not, is going to be the best idea. But the bottom line is some kind of vision about what the future of Earth's land should be like is, I think, essential if there's going to be any kind of management. The other basic rule we've learned from doing some assessments of what happens when you try to do conservation globally at 50% is that you have to do it in shared landscapes. There's no way to do it all by setting aside some kind of wild place far away. It's all going to be integrated together and interconnected. In other words, nature conservation is going to be right here at home with us. So in the Anthropocene, just some closing thoughts here. In the Anthropocene, we've said ecological change is social change. But the interesting thing here is the culture of humanity and all of us is changing in different ways. There's a lot of different types of cultures, but cultural values are evolving. They're not fixed in place. And just a brief story about this. I used to live in Beijing, and in the wintertime, pretty dismal. This is from 1990. In 1990, you know, it was just gray and cold in Beijing. Came out, sat in the park, and all of a sudden I heard some birds singing in the background. I thought, you know, it's not so bad here in Beijing. But then I looked around, and all the birds were in cages. All the singing birds were in cages. And that was about as good as you were going to do in Beijing in 1990. That was your nature aspiration, more or less. But things have changed. Things are changing with development, with opportunity. People are thinking a little bit differently about what they want, what kind of nature aspirations they have. And that's not just somebody abusing pandas, okay? That guy is funding all the panda work. And now the aspiration is a different kind of nature, really to keep things more wild. That's actually something that people now, it's common in China to think this way. It didn't used to be. And just a story of return. It's not the end of the world, okay? The wolf, one of the most reviled and difficult creatures to live with for humans, is now coming back to some of the most densely populated, highly used landscapes on Earth. And it's because people have decided to make it so. And it's not easy to live with a wolf. It's hard. So this has been a huge decision. So when we think about stewardship and Earth planning and managing, it's not this remote global practice. It really has to be thought of as something right here at home, right among all of us, a personal thing, something that we value, something that is part of us. Thank you.
Great. Let me ask you, I know we're kind of, let me ask you one quick question. Earl, don't leave the podium. Earl, or you can sit down. So you brought up something that Ken has brought up in different ways before when you said, shoot, where is it here? Yeah, we don't have a better vision. And I quoted Ken in 2015 in Paris at a conference, ahead of the Paris Climate Conference on Science. And he said, the climate community has focused a lot on presenting the vision of the future. We're trying to avoid, it's equally, if not more important, to present the vision of the future we're trying to create. But I know that lots of scientists feel kind of uncomfortable about envisioning things, and journalists too. But in journalism, there's this emerging line of journalism called solutions journalism. There's actually a website, solutionsjournalism.org. And it has that very same feeling of like, oh, how do we do this? How can we use journalism as we know it to move in directions identifying solutions? I think there's a thirst for the same qualities in some science. The only other articulation of that I want to mention is Dan Kamen and Michael Dove in 1997 wrote this paper on the virtues of mundane science. Just Google for mundane science, you'll find it. And that, you know, how much of what we're talking about is integrated in how you shape your work, your careers, and everyone in the young people in the room particularly.
Yeah, all I can say is I think it's not enough, I think, if you want to put out knowledge from your scientific work, you have to give it your social context. And I think it's always important to realize that you're coming from a particular place. Like a scientist, there's lots of different kinds of scientists, but just from my personal world, I try to always think, you know, my ideas are coming from my world. But everyone lives in their own world to some degree. So it's always about reaching out to find out what other people care about and trying to connect with them when you talk about your science. That's, I guess, the best I can.
And this is a good transition to the humanities. Oh, we're going to hold questions till...
So I would like to thank Ariel and Stephen for this invitation to have the humanities here in this panel. This is my first AGU, and I'm really happy to be here. So the outcome document of the United Nations 2012 Earth Summit, The Future We Want, calls for change in the ways in which environmental research is done, advocating for the integration of humanities and arts into natural and sustainability sciences projects and platforms at all levels. Even before the Earth Summit, humanists had long been working on environmental issues, at first separately as environmental philosophers, ethicists, historians, literary critics, but in the last 15 years as collaborators, creating a new field of the environmental humanities. This field has so quickly grown that it has thousands, tens of thousands of practitioners at this point, and probably every large university around the planet is looking to add new researchers, new programs, initiatives, and fundings. And so environmental humanities is a term that you're hearing more and more. The field, as I said, is so large that I can't do justice to it today, except to say that this slide lists some of the things that we do. We do things like teach climate fiction so that people and the public can imagine what it's going to be like in 50 years. So we're not asking our students necessarily to look at graphs and charts, but to read a novel, say like Paolo Bacigalupi's The Water Knife, which imagines Phoenix and Los Angeles in a water war. It's actually not so much an imagination, right? It's really already sort of happening. And so because it's only set 50 years in the future, the students can really sort of think about, well, what will the world look like as it starts to warm? So we're doing everything from teaching climate fiction to designing effective and just participatory research and policy processes. One of the most ambitious projects that is going on in the world is one that I'm attached to, and I'm very happy to introduce it here at the AGU, and it's called Humanities for the Environment. It is a consortium of 8 observatories headquartered at 8 universities around the world, one each in North America, Africa, Australia Pacific, the Circumpolar region, East Asia, Asia Pacific, Europe, and Latin America. Each observatory networks all of the environmental humanities programs in its region, and it networks all of the observatories to each other. The international website features projects at each observatory that are modeling co-designed research of food systems, glacial melt, desertification, coral bleaching, and more. And I will invite you to go to the website because I can't possibly do justice to all of the projects that are going on around the world. But if you want to see how we are imagining how you will work with humanists on your teams, then these are the projects that are trying to model that. Each project coordinates collaboration among humanists, social scientists, and scientists, but also looks to the insights that can be gained from consideration of the past and history, and the remarkable achievements in art, astronomy, science, landscape design, storytelling, mapping, etc. So some of those civilizations that Earl was just talking about a minute ago that maybe have disappeared, but some of the things that they were doing then might work for us now. We look to that. As we explain in one of the first books about the project, Humanities for the Environment, we're also interested in setting meta-concepts like the Anthropocene, and I'm going to call the Anthropocene a meta-concept because it's a concept that we're using to think with. Or sustainability, which is a concept that we use to think with. We can measure certain things, but we also use these concepts to think with. And so we want to juxtapose these concepts with older concepts that come to us outside of scientific discourse and are rooted in ancient civilizations. So we are looking at concepts like country in Australia. So in Australia, the Aboriginal people have been talking about country for thousands of years. It's a kind of way of thinking about sustainability. Or Oceania in Asia Pacific, or all our relations in North America. So all our relations here in North America means that humans are related to every species, from the microflora in your gut to the food and the plants that you eat, because each of these species actually makes you human. You are human because of your relatives in the environment. And so all our relations is another concept or way of thinking sort of at a meta level about sustainability. So I'd like to tell you about one of our projects from the North American Observatory. This one is looking at this concept of all our relations, and it involves an archive that we've put together on the website. We call it the Archive of Hope and Cautionary Tales, and we tell stories. These stories are about everything from Nepal to Michigan, and I'm going to talk about the one in Michigan today. But essentially, these stories are, the archive is a place where people can come to the website and look at how different communities around the world are exploring environmental problems in their regions and what they're doing about those problems. So today what I want to do is I want to look at one of these, just one of these stories that you can find in the archive, and they're all written in an accessible way so that anyone from the public can come to the website and read the story and know exactly what's happening. This one is called Renewing Relatives, Enmay Stewardship in a Shared Watershed, and it's written by Mary Holtgren and Stephanie Ogren of the Little River Band of Ottawa Indians in Michigan. And it is written in collaboration with a philosopher and Potawatomi Indigenous tribal member, Kyle White. And so humanists are collaborating with scientists, natural scientists, biologists, and Indigenous elders on this project. The Little River Band of Ottawa have designed and implemented a restoration and conservation program for the local fish, the lake sturgeon, which is rooted in this concept of all our relations, or building relationship. Kyle White explains that project organizers are working for something that they term collective continuance and define as, quote, a society's overall capacity to become resilient or continually adapt to social and environmental changes. And I want to suggest that this concept of collective continuance presents one model, just one sort of on-the-ground model for how we might think today about managing the earth, one region at a time. I also think maybe this idea of collective continuance might be the miracle of love and unselfishness that we've been talking about on the panel today. So the Little River Band of Ottawa Indians live in the Big Manistee River watershed. They've been there for thousands of years. And as you might already know, Anglo-American activities have threatened the stability of the sturgeon through overharvesting, dam constructions, stocking the rivers, etc. So the band has created the first streamside rearing facility for the sturgeon, and the program does more than just manage for a fish. So I want to juxtapose this collective continuance concept with the other concept we're talking about today, management. This program does more than just manage for one fish. It builds capacity for collective continuance among fish and humans. And the humans that it's building collaborations with are federal and local officials, nonprofits, groups, and all of the people living in the Big Manistee watershed. So the Little River Band of Ottawa are not aiming so much for prevention of extinction. They know that species are collapsing at a high rate. They can't save all the species. Rather, they've chosen the sturgeon, one species, one sort of iconic species, because everybody likes to go ice fishing in the winter. So they've chosen one iconic species to build a program around, not just because they're trying to save the fish, but because they want to bring people together to think about the watershed. So to build trustworthiness, which they believe is one of the capacities that they have to build in the community, they hold a ceremony and a feast every September that attracts up to 600 people who learn about Anishinaabe culture, the sturgeon, and its watershed. Each person is invited to then, after eating, carry one baby fish down to the river and gently pick it up in their hand. So you're touching the fish and you're putting it into the water. So kids do this, elders do this, middle-aged people do this. Everybody's putting a baby fish in the water, skin to skin. So all of the emotional things that you've been talking about that have been missing in programs in science, environmental humanists, we are trying to think about the ways that we would put these elements back into the research. Skin to skin, touching the fish, recognizing that that fish has to be 30 years old before it can reproduce. Therefore, maybe you shouldn't harvest it when it's small. Maybe you should let it. So people are getting together and thinking about how to, protect the fish, but it's bringing communities together. Kyle White says that these events do not aim to get everyone to be Anishinaabe or think in Anishinaabe ways or act in Anishinaabe ways, but rather people after coming to the event tend to come to feel a sense of themselves as co-occupants and relatives in a shared watershed. So the Humanities for the Environment projects around the world are offering templates or models for this integrative research that was called for by the future, in the Future We Want document. We're trying to show how interdisciplinary teams can come together to utilize the strengths of the humanities and the expertise that we bring to the table. At the heart of global change in the 21st century lies human choices and actions. Our projects are offering models for how communities on the ground, one by one, region by region, are building relationships to guide better choices and actions. Thank you.
Any quick questions, either from the panel or from the audience, before we go to the sort of full round of questions? Marta?
Can you talk a little bit more about collective relational capacities? So there's different capacities that have to be built for collective continuance.
Repeat the question.
She wants to know more about collective continuance. Was that your question? Collective relational capacities, and how Kyle defines that is that trustworthiness is one of those collective relational capacities, and ecological redundancy is another one. So you all are scientists, so you probably understand ecological redundancy quite well, meaning that the sturgeon can't be saved just by saving it in one place. It has to be flourishing in more than one place. I think maybe Earl was also talking about how different species have to be flourishing in different places in order to be able to flourish. But we have to teach people about that. So if people don't know that the sturgeon has to be 30 before it can reproduce, then they can't flourish in more than one place because they're being over-harvested and too soon. So that's one of the collective relational capacities. The other one is trustworthiness. And the program itself tries to build trustworthiness, trust between Anishinaabe communities and non-Anishinaabe communities, but also with the forest, with the Fish and Game and NGOs, all of the different players or stakeholders in the watershed have to come together. They have to learn to trust each other, and they have to do it not overnight, but over a long time. So there are different capacities that contribute to the collective continuance.
Great. Thank you very much. So I'm gonna do a round of questions, and hopefully there'll be some commentary and questions among this great panel. And Ariel, you should feel free to weigh in as well. This last issue raises something I've been thinking about a lot. My sense is, and feel free to argue, that the conventional definition of management, or the thing we have in our heads as management of something, isn't what everyone here is foreseeing as being applicable in a full way in the world. This whole top-down governance is another word for it. Global governance has been the vision, including at the UN, the sustainability process, the SDGs, who's going to tell us whether we won or not with the SDGs? And then there's this bottom-up thing. And it led me a few years ago, back in 2013, I was thinking a lot about numbers and the limits of numbers. 350, 80 by 2050, pick your number, AB 32. And knowing that you look at emissions trajectories, of course, they're not really abiding by our numbers. So what do you do? And you mentioned the trustworthiness. And what I did at that point was I started listing like characteristics. What are the characteristics of a system that give you confidence that you can have trust, that you can have the qualities that will lead it sort of organically in a way, not without direct management to go forward. And their transparency leads to trust. Right now, I'm just going to give you one quick example, and then we go get some reactions from the panel. China has sort of got its numbers on coal use and emissions have gotten what some people think is more accurate recently, and it's largely because the world can kind of verify all that now. Remote sensing, there's this coal, what's it called? There's a satellite photo tracking of construction activity at coal-fired power plants around the world. No one can kind of just sort of make up numbers anymore like we did in the old days with the Soviet Union. You know. So that's an example of trust comes through the old Reagan idea of verify. So what are the other qualities? Could you list what would a world look like where you could step back and say, wow, it's kind of working the way we would want it to work? Maybe you could just go down the chain, like yell out some qualities.
So,
or characteristics.
I don't know if this is working. Is this working?
Yeah.
Okay, so for indigenous people, obviously, the issue of trust is huge because so many treaties have been broken. So one of the qualities of trustworthiness is just being there over time, or
right.
Making sure that if you make a promise, you come back and you fulfill that promise over and over and over. So trustworthiness is not something that can be built overnight. It takes time. So I think
sustained engagement.
What?
Sustained engagement.
Sustained engagement is a good way of putting it.
Earl?
Yeah, I think, and I use the term design, talking about Anthropocene design, but it's really co-design. So it's the idea that when people are trying to build something different than what they have now, that it's not something that everyone gets brought in at the end and told what is going to happen, but there's a consultative, negotiated process of deciding what's going to happen. So that ability to collaborate in decision making, I think, is pretty key.
Are you implying an iterative learn and adjust kind of a model there?
Ken and I were talking earlier, and the concept of Sisyphus comes to mind. It's an endless task.
Yeah, but is it more like the movie Groundhog Day? Where it gets a little better each time?
I don't think it's Groundhog Day because things are changing a lot. But at the same time, it is about, it's a perpetual process. It's not like we're going to fix the problem and move on. So we're going to be constantly doing this.
Yeah, I don't actually disagree with that at all. I think sort of observations that are objective and sort of revisiting them, and then we're continually evaluating and learning about new stressors and new things that we care about. And so evolving again, as a modeler, evolving our models to understand this and to represent the observations and to represent things that people are interested in knowing about.
Ken, what do you think about this?
Yeah, I'm not sure I'm going to answer your question, but just this, you raise the issue of management. And to me, a lot of management is coupled with this idea of urbanization and intensification of agriculture, and this idea that, well, we can have a managed world in which there's more wilderness or more unmanaged territory. And it just seems like crazy. I heard some report about some of the last old growth forest in Romania being cut down. In the Pacific Northwest, they're still cutting down old growth forests, which in this day and age just seems insane. And so, but part of the trust is like, if you have people in Oregon who make a living from lumbering, you need to get trust of those people that you're not just saying, look, you're going to live in poverty because we want to protect old growth forest. And so it's some complex thing of that, well, we need to provide people with good lives if we're to protect good ecosystems.
You remind me, Paul Hawken, who's now known best through the Project Drawdown, listing 100 ways to take CO2 out of the atmosphere. He told me a story a few decades ago during the Northwest owl forest wars. He was involved, I guess, with some efforts to get these communities to talk to each other in a way that, as we were saying a minute ago with Jody, is a trust-building exercise, finding common ground. And it's everything that we haven't been doing in the way the environmental community and many other communities have been dealing with each other.
Yeah, I mean, just a story that at Stanford, there's a group of climate people working on communication issues, and they came to me and talking like, oh, we're going to go out to farmers in the Midwest, and what should we tell them? And I said, well, the first thing you should do is listen. And
Right.
not assume that all the information transfer has to go in one direction, and that, if you want to build trust, a good place to start is by listening.
So sustained engagement, listening, those are pretty good things to write down.
But
And-
just to emphasize, building trust takes time. And time is something that
Right.
is so hard to come by these days because we're running 1 million miles a day. We're on our cell phones. We've got 300 emails waiting for us in our office, or more. So time is absolutely a quality that's going to that's at issue here when we talk about trust. And so I think that we'll have to find the time.
So somehow or other, some top-down people have to grant time. And this is what, Kate, I think this relates to modeling too. I remember writing about sea ice. I was talking to Marika Holland at NCAR about her sea ice modeling, and she had never seen sea ice. I think she's never been to the Arctic, and we were joking about whether there should be a field trip to the Arctic for modelers, and basically to get observational scientists and modelers together more.
I've been involved in sea ice modeling exercises, and I've never seen sea ice.
There you go.
Except from an airplane flying.
All right, so
over
there's a
Greenland,
to-do
but-
list thing. Can we get Ken to see some sea ice?
I mean, I've actually, the only field work I've ever done is measuring trees, which, but I think working on the human system side, I think doing field work in that arena and going and talking to people, talk to the farmers, talk to building managers, talk to these people and figure out what they're interested in, what their concerns are, rather than what I think the modeling community often just does is say, this is what it means for global mean temperature or global GDP. But that's not the full suite of things that we care about. So
And I have one last question before we'll turn around for the audience. And this is sort of for Earl, but also for you, Kate, I think. Well, maybe all of you. It's about, are there sort of, the people I know who model the atmosphere do sort of nested modeling, looking at smaller systems that have similar qualities and the like. And I think about the Adirondack Park, for example, when I think about the Anthropocene, because it's got snowmobilers and hunters and landscapes that are pristine and ones that are completely reforested that you would never know were cut, and human communities and landfills. Are there other, is it valid or useful to look at some of these sort of microcosms as a way to look at the bigger cosm?
I think there's definitely a fractal nature to the way the Earth functions in every process, really. And social ecological processes are like that as well. So just like, when you look at your yard, it's not one thing. You look at the planet, it's also not one thing. There's a tendency to think, well, we can just study agriculture or we can just study forests. But in fact, they're always interacting together. So you can to some degree, but it's not enough, because there are some things that work really nice at small scales. Biofuels is a great example. As a marginal activity, it's just fine. When you scale it up to a planet, it's very destructive. So you have to work at the different scales. You can't just assume that something that works really nicely at a small scale will always scale up well.
I completely agree. I think we need to sort of think about both from the bottom up and the top down in different scales, because I think that certain things are easier to represent at small scales but might have implications at larger scales, just like Earl said. And I think also, depending on the question you're asking, you might not be able to represent it at a coarse global scale or at a fine scale, depending on what it is.
Great. Or so let's see. I think I see Michael Ellis has a question.
Should people go behind the
No, we'll
line up behind the mic?
Sorry.
Do you want people to line up behind
Oh, if you could go to the mic, that would be ideal, so we don't have to keep repeating. So, and while they're lining up, I have one more question, not to waste time.
too late.
So I spent some time at EASA. Oh, no, give me a second. This complex systems place outside of Vienna. I was there 2 summers ago when it was 100 degrees for a week. And they do this really interesting long time scale modeling, like what I was mentioning with Herberto Cabezas and Wolfgang Lutz and others. They really dig in on demographics And it's so interesting because they do these papers that say, like in the year 2300, there are scenarios that they run that come out with a world of like 2 billion people, tons of room for nature, and, you know, basically functioning, prosperous people, and no calamity between now and then. But that's like just the starting point to me. It's like, so who in science or wherever else fills in the blanks and tests what that journey is like, and how much of it is about getting girls through high school in Nigeria, and how much of it's about, you know, a better energy system and that kind of thing. Is that already being done? Are there people who are integrating, looking at the outcomes that are conceivable with numbers, but in a way that builds the conversation around how you would get there?
So through 2300 or just in the future in general?
I mean, in a general sense, you know, pick your endpoint, 2100, 2300.
So through 2100, there's a lot of people that look at sort of the, you know, if we have different population scenarios, different energy technologies available, different agricultural and those things, and how does that all play out? And then what if we try to perturb that system? What does it look like? But most of those actually stop in 2100, which kind of made sense 20 years ago. But as we progress in time, we don't seem to extend our models. And so the only people I know that go into the very far future is some of the Earth system modeling. They'll do stylized scenarios out there because they're really concerned about things like carbon cycle effects that we're affecting now.
Right.
And it'll have, you know, century scales.
Right.
But I don't know of a lot of people that are doing sort of very, very long-term human and working backwards from there.
Unless you count science fiction.
Kim Stanley Robinson, right?
Kim Stanley Robinson, absolutely. Right. I mean, he reads broadly. Everything he writes is based on what's plausible.
Good. Oh, now Michael, sorry.
Okay. Thanks. This has been a very interesting panel. I'm Mike Ellis, and with Earl Ellis and Andrew Revkin, I'm also on the Anthropocene working group, so I have some extra stake in this. Well, I guess we all have stake in this. One of the things that you've not talked about, but Joni, you've touched on it on a small scale, is the need, if we're going to manage the planet, is the need to have widespread behavioural change. And as an example of how difficult or how easy that can be, a year and a half ago, or thereabouts, David Attenborough, who's a naturalist, or kind of naturalist journalist, hosted a TV program called Blue Planet 2. And this particular episode was about plastics, plastic bottles. And that single program motivated so many people in the UK, at least, I don't know how it played out here, that the Conservative government, I say that with temerity, actually changed their policy. They had nothing about plastics in their manifesto, but they actually put it in there. And there was tremendous sea change of regulations being talked about, hasn't come out yet. But the point being that single event, that television program, changed a lot of people's minds about something that's very important in this context. So the challenge of large-scale behavioral change is something that you guys have not really talked about, and nor do we have somebody like, you know, somebody up there in marketing or psychology who deals in behavioral change, because it's a very difficult thing to do, because it implies things that have to do with Madison Avenue. So I just want you to comment on that.
Yeah.
So the Humanities for the Environment project wants to do something like that. We're all obviously still at a very small scale, but our idea, the question we started with is how would we scale up? And so each one of the projects on the website presents itself as a quote-unquote open access template project and invites people to come to the website, other communities to come to the website and say, oh, this is what they're doing in the Big Manistee watershed. I'm in Nepal. This looks like it might work for me. And so each of the projects, although in narrative form, is actually based on projects that are going on in communities and invite people to come in, look at what's going on, and model, adapt, scale up, replicate.
And I'll just briefly say, at National Geographic Society, I'm at the grant-making side, not the magazine side, which is, and we now have a big endowment because it's too complicated to go into. But one of the grant tracks right now is grants for research on making the case for nature. That's kind of like the shorthand version. And it's pretty much social science research. And it goes beyond marketing. It's sort of like what works and doesn't work, assessing carefully how that can change or not. The science of looking at what happened with Attenborough and or how that is reflected in policies on plastics. I think Australia is also 2/3 reduction in plastic bags in 2 years. So there's science to be done in this arena. Of course, for this panel, I think that we need a new grant track, making the case for the future, ? And I think that's in one of these really important arenas.
I think one critical factor, though, is to realize that so-called human behavior, there's lots of different humans, obviously, with different behaviors. But that human behavior is extremely flexible and changes very rapidly, already has. Think about what you were doing 10 years ago to communicate with other individuals. You probably weren't on your cell phone, okay? But now you are, and it'll probably be something else. So the idea that we're not in a position where things can change dramatically, almost completely, is not the case, right? That things could change. Things do change. The question really is how to change things in ways that make us all better off, and without, in a sense, doing the social engineering. It's a tempting thing to think about it, but it's been tried, and it doesn't usually work out so well in the end. So what's the middle ground? Where do you go between, forcing people into some type of behavioral pattern, if it's possible even to do it, versus influencing, guiding people into things? And the other good thing is that there is a tendency toward tipping points in social behavior. Once you get past a certain point, it may not be cool anymore to have a car with gasoline in it. That can change, and you don't want to be the last guy on your block. So there can be big changes. So we shouldn't be thinking about the end of the world and that we're just steaming toward a wall and we can't turn away. We are constantly changing and turning. So how do we change better? How do we turn better?
And just examining the mental models, what is the mental model in the room of success? Everyone, write that down on a piece of paper and share it with someone else and see what their model of success is. Next question.
Yeah, thanks for a very stimulating discussion. In the title, Can We Manage the Earth's Future? I think there's a subtext that we are all individuals and we have equal agency in the world. I think that's really not the case. And to look, not to quote Bernie Sanders too much, but we have a billionaire class, some of whom Ken Caldera advises, but they have inordinate political power. We have huge disparities in wealth and income inequality in the world. We have a growing surplus population, including many of the graduate students here, that will look forward to a future of precarious employment. And so the question is, who is we? And I do have some hope. I heard Lisa Jackson speak. She represents the good wing of capital, the green capital, which is looking forward to a Green New Deal, and we have a great initiative in Congress on that. But on the other hand, we have a fossil capital, and our president is clearly a representative of that. And so I would submit that the political economy of the world is not being analyzed in this panel. And the class interests that exist in the world are not being analyzed, and I think that has to go to the root. Because if the IPCC report of October said we need radical changes to keep the warming under 1.5 degrees, who's going to do it? The billionaire class? Right. I don't think so. I think we need a global subject of people all over the world to do it. And I appreciate Ken's appeal to a spirit of cooperation. And the last speaker gave actually a concrete example of how that can be manifested among indigenous communities. But I would suggest that we need to have a new perspective on the political economy of the world and not simply deal with technical issues. Well, so that's my comment.
This is great.
So can I comment on that?
Yes, sir.
So the environmental humanities does study that. That is exactly what we study. One of my colleagues, Rob Nixon, who's at Princeton, likes to say that there are two stories of the humanities. There's the story of unity, which is what we could do if we all came together to do something. So one story that talks about the quote-unquote royal we, what we could do. But there's another story of the Anthropocene, and that's the story of fracture. And that's the story about all the disparities that you're mentioning. So I want to say that the environmental humanities is a huge field, tens of thousands of practitioners around the world. That is what we study, and that is why we need to be on every team, because we do bring consciousness and knowledge of those disparities as well as the unity of what we could do if we work together.
Great. Ken, a quick thought if you had one.
Yeah, just to say that, your comments I find resonant, and I think this is an area where some more historical analysis. I'm fairly ignorant in this area, but to understand, like, when in times in history did a less powerful group gain political ascendancy over a more powerful group, and hopefully did it in a nonviolent way? And are there lessons to be learned? Because I mean, obviously, in this country, we have a narrow group that's becoming more deeply entrenched in what's becoming a non-democratic system. And how do you transfer power within societies, and how has that done successfully in the past? I think is something we need to pay more attention to.
And there's tons of scholarship on this too, as you just heard. Just search online for Capitalocene. Jason Moore wrote a book on that. It's that it isn't the Anthropocene in the sense it's not everyone on the planet who has created the situation we're in on the planet. So,
yeah, I mean, just there was also this comment about the unit of analysis. We're supposed to be scientists analyzing things in scientific units, but if you see when many times scientists are doing analyses and the unit is the country, and what's the national level emissions where there's so much disparity of ways of living within each country. Does it even make sense to use countries as a unit of analysis in scientific research?
Okay, let's get some more questions on the board just to keep things moving. Yes?
Yeah, the discussion so far, I think, has been a very optimistic one. It sort of assumes that, yes, we can successfully manage the Earth's future. But following up on the last comment, with the Koch brothers and given where our fossil fuel industry is going, there's a very high probability we'll hit 2 degrees C by middle of the century or sort of thereafter. So what do we need to have a discussion that says, how are we going to manage the future if it's not a good future and we are headed well over 2 degrees?
I have an answer, but...
So the only answer I can give you is that the community that I engage in, we look at different plausible future worlds and what they mean, and then what happens if you try to move off of them. And so there are different, I don't know if you're familiar with the shared socioeconomic pathways, there's these 5 different economic futures. One is this storyline where we're all it's a very high GDP per capita, low population world where we've invested a lot in fossil fuel development, and you end up with high emissions absent any mitigation. And then you can take that world and look at what were to happen if you were to try to change something in that. And so we can use the models to sort of play out those storylines and what does that mean. There's other futures in there in that set that have a very different characteristic, and they'll have different implications going forward into the future. And so that's how we sort of think about that problem, not directly with the forcer, but more of sort of what are the uncertainties and how we unfold and what do they mean.
And I'm just going to quickly add, this gets to what I was saying earlier about solutions journalism and thinking about solutions science. Volkswagen, that's just that one word. How many people think the Volkswagen thing was revealed by a journalist? How many people understand it was revealed by a laboratory? Yeah, West Virginia University Laboratory with a $100,000 grant from a tiny nonprofit group that is focused on clean air and transportation. Think about the untapped potential on college campuses to impose transparency on big companies, whether they're owned by the Kochs or anybody else, that is not being expressed. It's fine to be marching in the streets. It's fine to be active around a number like 350, but I'm thinking it's not fine to visit college campuses that have that potential, and journalists as well, with academics, to fill that gap. It's all around us. How many universities are you at that have labs that can do things that can ask questions, that can use infrared imagery to see where there's leaks in something or whatever. The capacity is there. The motivation, I think, is not yet there, and it's partially because of the academic models we have for how you get ahead and all that stuff. Unless I'm wrong.
I mean, just this question's kind of interesting because most of the adaptation research that I've read has to do with more near term and adapting to worlds where the climate change isn't so bad. But if you take the sort of real doom and gloom climate change where you have, you know, mass starvation, mass migration, wars, and all this kind of stuff, this question of how do you adapt to that kind of world is an interesting one and not one that I've seen addressed well.
We're doing a workshop yet next year at the World Conference on Science Journalists about how to tell some of those stories. Any last question?
Well, I think an archaeological perspective on what happens when societies face severe environmental challenges like a sustained drought is very informative, because some societies that have enough social capital are able to weather these bad situations by building irrigation systems and granaries and coordinated activities. They have the social capital to do better. And some societies don't, and they collapse.
Right.
Is it the environmental problem that is causing the social problem, or vice versa? Arguably, building social capital is useful no matter what. So I would argue that's what we should be thinking about. And if we can do that, the future will be better, whether the environment is more challenging or not.
And just quickly, the reason why I chose the Big Manistee project to talk about today is because it's a bottom-up project. But it's a bottom-up project that's based on hundreds of years of surviving apocalypse. So indigenous peoples don't think that apocalypse is in the future. They think that it started in the 1600s. And they're still here. And so when we talk about climate change, there's a lot of voices in the indigenous community that say we should be looking to them, not because of romanticized ideas about how they lived in the past, but because they're still here. And because they know a thing or two about essentially what you're talking about, social capital, how to put together new projects, for example, that look to the future.
Next question.
Hi, my name is Kaki Rodway. I come at this from an architectural conservator point of view. I actually worked with archaeologists, so I'm glad you brought that up. A couple things. One is a point in terms of modeling, and I worked with archaeologists who looked at remote sensing data and then did ground truth observations. They went to the fields, they went to the sites, and they actually saw what they saw in the images. So that is what I would like to think about with respect to the built environment. My question is, why does nobody talk about the built environment? Or you talked about it a little bit in the sense of villages, but, and this was a point I brought up to Jeff Sachs, because I grew up, people need food, water, and shelter. And we're not really talking about the built environment in the sense of how is climate change going to impact our cities. Most of the coastal cities here in the US are historically significant cities, right? So there you bring in stuff like the economics. It's tourism revenue, it's income for people who work there, it's transportation. I mean, you add these multiplier effects on there, and you have cities like Savannah and Charleston and Newport, Rhode Island, New York, who are able to be the capital influencers that they are, that they're able to, in a sense, sustain their state or their region. Why is nobody talking about these cities and looking at the urban environments? And if they are, if I'm wrong, who is? Because I would like to work with them and talk to them, because coming from my perspective, I haven't found them. I found earth scientists who are, but not this nexus of people who are looking at this problem as a whole.
There's this brand new open source book, Urban Planet, Thomas Elmquist, Stockholm, and many others. Earl, are you in there? I can't remember who's. I wrote a piece for it. It's a great, it is the community you're looking for. So just Google for urban planet or email me and we can, that's one thing I would add.
I was just at the Harvard Graduate School of Design for their final exams in landscape architecture, and the theme of one of their major studios this year, for the first time ever, was climate change. Every design was focused on climate change. And I can say, you know, those folks really did get to places that I haven't thought about. So the design world, even though there was kind of two parts, why aren't we thinking about it? Well, some people are, and they really are trying to address this. And the truth is, there's going to be a lot of money made in infrastructure that can deal with climate change. It's a growth area, but the nexus issue is a harder one. Like, how well are they able to interface with the other disciplines? And they work at it. I mean, designers are really, they do try and draw in information from everywhere.
Wow.
This is the first time. Yeah, I was surprised at that, but it's
well.
True.
Yeah.
I can do an archaeological remote sensing model and bring wireless sensors and put them into buildings and measure the water absorption.
Well, I saw two themes in these designs, and one was more or less retreat from the coast, retreat from the parts of the infrastructure that are no longer sustainable in the face of, say, frequent fire, frequent flood, saltwater intrusion, this sort of severe storms. That was one theme. The other was, I thought a lot more hopeful and probably maybe in the long term more effective, is trying to pull the society at regional scale toward different development. So trying to build infrastructure that encourages people they want to be in a different place. Because it's once people are built up in a place, it's very hard to get them to move. So, you know, trying to facilitate a kind of a way of thinking that people want to move to another environment rather than just being forced to after the big event and the insurance no longer covers it, the government won't rebuild them for them, et cetera.
I recommend you get to the University of Pennsylvania next June. There's a new thing there, the Ian McHarg Center at UPenn, 50th anniversary of his book, Design with Nature, and it's all on this point. They asked me to write the foreword for this book, and I'm way overdue to do it, because I wrote his obituary for the New York Times. Here's this one thing that Ian McHarg said, exactly what Earl just said. He was this amazing Scottish, you gotta know this man. In the 60s, there was a documentary, he goes, "I've spent many years of my life offering my palpitating heart to various people who couldn't care less. Palpitating heartism doesn't really get you anywhere at all. You have to do two things. One needs to be able to say don't, but you also want to be able to say do." And this is that envisioning thing. And just go to UPenn next June. Another question.
Thank you. I loved that comment about modelers going out and talking to people, maybe in the field, so to speak. It really made me think of these comments that I kept hearing at the last few fall meetings, scientists talking about they have to get out of their labs and go out and advocate for science because of this anti-science environment that we're living in right now. So do you see a connection between those two things?
I mean, I think understanding people and what motivates them and how they make decisions is all part of that same vein. And I think when we're trying to understand how what the future looks like, understanding what's motivating is part of that. I mean, I think it wasn't specifically what I was mentioning. I was just sort of thinking about, like, particularly I do a lot of land use change modeling, and so talking to farmers, particularly outside of the U.S., would be a valuable experience for me. But I think it's related there and sort of understanding people.
Hi, thanks everybody. Tyler Volk, NYU. So just a couple numbers that kind of are on my mind almost daily as something to contemplate, and whatever direction you want to take this to comment on would be fine with me. So the GDP per cap in the United States is something like 3.5 times the world average, maybe 3.5 to 4 times the world average. Aspirations of people around the world are to live better, That's happening. Energy is increasing. Buildings are, the infrastructure, the built environment's going up like crazy. There's a group out of Austria showed that there's a strong correlation over the last 100 years between the material stocks of the world, the actual material things between people, and GDP over time. And so that's going to rise. And the world population's going up, maybe about 30% more than what it currently is. So if I put together aspirations towards Western lifestyles times increased population times the fact that many people in the developed nations themselves, want more, and and I'm pretty happy where I'm at, but I think I could be 6 times the world average GDP or something. So the number that gets meditated on in my head, and actually I get my students to think about, and it's not an answerable thing, but we may be heading toward, when you fold all those things together, we may be heading toward a world of 6 times gross world product compared to today. And that number doesn't get talked about very much. I think it's a staggering thing to think about, because then we think about the stocks that are going to be going into place. And now the energy, fortunately, is not going up at the same rate as GDP, but we could be talking about 2 to 3 times world energy to get 6 times GDP, world GDP. So I just want to toss that out as a kind of a stone in a lake and see what kind of ripples come out from you all on that.
Translation, are we screwed?
I mean, I think that there is sort of this increases in population and income and changes in lifestyle are a stress of themselves. And so there's a lot of work. If you look at things like water scarcity, and there's people that look at, how will water scarcity change in the future as a product of changes in the Earth system versus changes in human system. And they usually find that in most water basins around the world, the human development is the bigger driver. So increases in income and diet, changes in diet and things like that end up causing a bigger water footprint than you might see from the Earth system side. And so I think that looking at changes in GDP in the future and changes in population and behavior are really important, because they do end up affecting the future. I'm not sure I want to say that we're screwed, because I think, as we talked about earlier, people are amazingly innovative, and there's lots of technology options that we can look at that might move us off of the more negative pathways.
Yeah.
Humanists tend to be a lot more not as optimistic as sometimes maybe, let's say you had 10 humanists who came to this conference. Maybe we would find quite a bit of optimism that we don't normally sort of project in our own conferences, because we're really looking at history. We're looking at all of the statistics that you just mentioned, and we're carefully sort of studying the disparities around the world. Who's having to move already, who's not. You mentioned social capital. Most of the most vulnerable people around the world don't have that social capital, so they need to move, but they actually don't have the economic means to move. So we tend to be a little bit more sober, I guess you would say, as we think about how we're going to create that future we want.
I'm a techno-optimist, but a pessimist about the ability to change human psychology. And I think the possible way out of that is really through this kind of cultural change that, for example, I think a lot of people are motivated. People want to avoid embarrassment or something. And if all of your friends had electric cars, you would be embarrassed to be the one person with a car with a tailpipe. And so I think that there's, while the human psychology can't change, I think the culture can change in ways that would reward better behavior. And so, it's a thin, maybe a thin hope, but I think that's where the hope has to be placed, and then we can develop. I think once there's the cultural motivation to develop the technologies, we can do it. But
because one way to look at it is like 80% is still to be built, of this world, and that could be a a certain kind of message that means there could be a lot of changes happening.
Well, and you know, of course, and to build the right kind of energy system for that 80% costs more, and we're not even willing to pay the cost differential for ourselves.
Yeah.
Well, that's right. I think, Tyler, I was with you in 2003 when Richard Smalley gave his Energy Challenge lecture at Columbia.
Yes.
You know, and what he did was he tied together a Nobel Prize winner who passed away way too young in chemistry at Rice, who he made his own list of all the world's great problems, and he said, well, you know, the one thing that ties them all together would be a cheaper, clean energy would really help address all of these things. And so this is an and thing, the cultural evolution and you know, some kind of intensified look at energy systems that can give us the services that you would want for everyone without the outcomes that we don't want. There's another question standing there.
Less of a question, just more of a adding to some of the comments from the audience here with regards to where there's innovation happening. I think climate change pushes us beyond our boundaries to solve it in terms of our association with individual, self, region, global. And so communication and technology paradigms are changing to be able to address those. So for example, I think it was Catherine who was saying, you know, I'd love to talk to farmers in other countries. Well, we have a platform that does that, with ground truth models around climate change at IC Change. But here at Thriving at AGU, there's a lot of work with regards to solutions-oriented science, just like Andy was suggesting, with regards to resiliency in the urban communities. Science is starting to reach beyond its traditional tent to be able to kind of do science and service for community. And you'll find that people who work as engineers or designers on infrastructure are tackling these things, and you may not be hearing about them, but I encourage anyone who's interested in hearing where solutions are happening around this to push beyond the science community, because those conversations are happening in practice with city managers in infrastructure design conversations and using kind of technology around community source science and community source storytelling.
And it's IC Change, ISEE change.org, right?
It is. We have we're on iOS and Android as IC Change Tracker, and you'll see a feed all around the world of people talking about change. And we do pilots in specific communities around urban heat and urban flooding. We add sensors to the mix, we add rain gauges to the mix, and we can actually ground truth the model data very well.
Great. So I'm going to turn the podium over to our organizer, Ariel, who's managed things very, very nicely. Thank you.
Sure.
For the last question.
So I've got an exit question. I've been sitting here quietly, which those who know me know that's kind of unusual, actually. I'm sitting here quietly because it's been a lot of fun, actually. It was a lot of fun actually getting you guys together and then looking forward to this. And so it's been fun listening, and it's fun and awesome because this is a really productive kind of conversation that needs to happen across these disciplines. And even so, as somebody pointed out, we're missing some key disciplines here: religious studies, history, psychology, marketing, right? If we really want to talk seriously about the Earth's future as a design space, all those areas need to be here too. And so I'm sitting here listening and thinking that, you know, somehow we need to have institutions around the world that bring those disciplines together to have these kind of forward-looking conversations about the future of the planet, the future of humanity, and how we all work together across disciplines. And I'm thinking, man, what a challenge. Then it suddenly dawns on me, you know, the light bulb. Well, we actually have thousands of such institutions. They're called universities, right? That you bring all these people together, and yet we aren't having this kind of conversation at most of them. In fact, I would say none of them, at no university I'm aware, even AFCU, which we like to be very proud of, is having these kind of conversations. It's engaging only a small, narrow segment of the faculty there. So why is that? And how do we change that? We're all academics. This is our, you know, change begins at home. That's our home. And yet we don't see those conversations happening. What could we do? And this is for you too, Andy. Sure. What could we do to actually foster those this kind of dialogue at these intensely multidisciplinary institutions that are probably the key to this, right?
Yes.
Or could be.
I'll just start. Increasingly, I wonder whether the departmental structure at universities is now an obstruction, and it almost seems like if you randomly assign people to offices, people work with the people who they talk to at the coffee machine or down the hall, and you know, I think some more sort of random sorting of people at universities would help a lot.
So I don't work at a university, so I can't comment directly on how universities.
But you've been there.
I've been there for a long time. But I can say one of the things that I think was great about this is just invite people from different fields to come and talk. And so I have been trying to do at least once a year going out and doing seminars at different universities. And I get invited, sometimes it's the forestry school, sometimes it's the economics department. I'm going to an earth systems school next. And I think if you maybe just start by inviting people to come and to talk, and maybe people are more willing to do it.
But how do we drive this kind of conversation? I mean, you can assign the offices randomly, great, right? But they're not necessarily going to talk about this. In fact, there's kind of taboos against talking about this in certain parts of academic culture. So, keep going down the line.
Yeah, I definitely feel that it is a challenge given the university structure to have a focus on. I mean, what we've been talking about is kind of the grand challenges that cannot be answered by any single discipline, and Anthropocene.
It's the grand challenge.
Anthropocene thinking gets you there. Like automatically you realize there's some really huge challenges that can only be dealt with by addressing them across the expertise that we have. So it would be nice to see that actually become perhaps a discipline. In geography, we do have a little bit of a precedent for that, although there's just as much precedent in geography departments, even though we may have, social scientists and humanities scholars together with, physical geographers, climatologists, et cetera, in one department. There is a tendency for everyone to kind of divide up, are you physical or are you human, and then people just go ahead and do their own thing anyway. So having solutions-oriented activities, solving a problem. And that's one thing I have noticed in the design world is that it's all about doing something.
It's the power of the word design.
Yeah, the studio and right. To accomplish something with a project. That brings different things together in a good way. And I guess there was one other.
So I think a first step is doing exactly what this panel is doing, which is making sure that your conference is interdisciplinary, inviting people from outside your discipline to the discipline. Humanists regularly invite scientists to all of their, environmental humanists always invite scientists to every conference. So we try to walk the walk, not just talk the talk. I spent about 7 years putting together a book called Keywords in Environmental Studies, and the challenge of this book and the reason why it took so many years to put together is I had to find a third of the writers would be scientists, a third would be social scientists, and a third would be humanists. But scientists don't want to write for a book that it isn't going to get them credit in their own discipline. So it was super hard to get scientists to write for the book. Tyler wrote for the book. So in other words, he stepped up to the plate and wrote one of the keywords. So keywords, I talked about keywords in my talk today. I called them meta concepts. We have to come together and agree on certain keywords, and to do that, we have to talk to each other. So what do you mean when you say the Anthropocene? What do you mean when you say biosphere? And this was a really interesting process because we had the Anthropocene working group writing Anthropocene. So they're the experts on the Anthropocene, right? But it turns out that they had to write for humanists. In other words, humanists had to understand the keyword, and that's a little bit more difficult. So it was a really interesting process. Everybody writing for everybody else, making sure that the language was accessible. That's a first step.
All right, and Andy, a final comment, then we're going to be kicked out of this room.
Yeah. Basically, this has to go back down before the university level, among other things. And there is active work and exploration in secondary and primary school on geo-inquiry, on inquiry-based learning. Just that alone, this issue, discourse around a word. And I wrote a long feature story for Anthropocene magazine on my Anthropocene journey, and the key thing I said about the Anthropocene was not the discussions we had in Oslo and these places on stratigraphy. It was the conversation that has emerged around the word. It's the only word for our time that's really, except maybe sustainability, that's generated Capitalocene, Plasticene, Pyrocene.
Plantationocene.
It's this kind of like opportunity to, but it's right. Kind of inquiry-based learning is the key thing at every level, but and there's ways to foster it.
Great. Thank you all very much, and sorry we have to evacuate quickly. Thank you for staying.